Hello everyone. So in this video we will have a demonstration on the previous code that we have tried. So yes, so don't worry about this design, this line connection and all this I created in the simulation environment. This looks messy, you can forgive me for that. So it's almost the same diagram we created in the previous demo. So 5 LEDs and 5 resistors, and the first LED, second, third, fourth, fifth LED. So first one is connected to pin number 3 and second one 4, 5, 6, 7 pins. Okay, you know that, right? That's fine. So this is connected to pin number 3, this is pin number 4, pin number 5, pin number 6 and pin number 7, and there's a reset button here, a push button that is connected to pin number 2 according to our code, and the other side is connected to ground because it's input pull up. Input pull up means what? This pin number 2 is internally connected to a resistor with plus 5. That means initially this is plus 5. When you press the button, this connection between this this point and this point will be created, and this point is ground. So ground will go here, 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 here and to pin number 2, and the plus 5 will fall, resistor will fall within that. Plus 5 resistance will fall within the internal resistance. So in simple words, the pin number 2 was plus 5 already. Now when we press the button, it will become ground. Okay, when we release the button, this connection between this terminal and this terminal will not be there, it will be removed, and the pin number 2 will be again in the plus 5 state with the internal resistor. Okay, so this is an input pull-up scenario explanation that I have already explained in my previous videos in the digital input scenario. So you can go and watch it as many as time you want until you get the understanding. Okay, so this is not the rocket science, but we can't explain it here because it's another thing. Okay, so according to our code I'm sorry guys, according to our code we do all these things properly. Sorry guys, and we read the value during each and every iteration. We read pin number 2, right? So that is why we have connected the push button to pin number 2. LEDs are going from 3 to 7. That's why we have connected the LEDs from 3 to 7 along with the resistors of 330 ohms. Okay, see pin mode 2 is input pull up. Okay, that is why we created the input pull up circuit, or we created the input pull up circuit, and in the code we mentioned input pull up. You understand? So you know why we mentioned. We know we want this 2 to be connected to the internal circuit of input pull up. We just have to connect the button only now. Okay, you get it? So you know all these things in the previous videos, earlier videos in the input pull up tutorials of mine. Okay, otherwise you can go and watch them and come back here. Right now everything is fine. So our button is connected to pin number 2 as we say it here, fine. LEDs are connected to 3 to 7, that's also fine. So if the button is pressed, X will become 0 and we will break the loop. That means no matter in which LED we are now, we will switch off everything immediately, and that means we will come out of the for loop and switch off everything immediately. That means we break the for loop and switch off everything immediately, and we will start from the beginning, first LED. Or in other words, no matter what is the LED location now, switch on location, if you press the button, everything will go off and the circuit will start from the first LED again. Okay, I explained it also in the previous video very well. Okay, now this is a continuity, so I cannot explain much, but we have to have a demo only here. Okay, let's go for the demo. So let me copy the code and I'll come to this environment, the code. Okay, I pasted my code. Now I'm going to simulate it. Let's simulate. Simulation started. You can see LEDs are switched on one by one. So let's see how this normally works. 1 2 3 4 5, and everything goes off. 1 2 3 4 5 goes off. 1 2 3 4 5. So the only thing is, after everything is gone off, there's only 500 millisecond delay time. So that is why it looks like the switched off of the last all the LEDs, and immediately after the first one is switched on. So if you want, if you notice, when all the LEDs are switched off, okay, everything gone off, and immediately the first one starts on. So sometimes you may not be able to see that properly. So if you want, what I can do is I can increase the delay increase the delay that we have after all the LEDs are switched off. Okay, maybe I will make it 700, not that much, just 700 is enough. Okay, and I will start the simulation. This will make some sense. You can see everything is off for a particular time. Then the first one will start. Okay, now it's beautiful. See the flow. Everything is work as expected now, right? See the off state, all off state will be 700, but still there's a small problem. So this is because that means we cannot see much of the time. Everything is staying off. It looks like immediately the first one starts again. This is because of the simulation environment issues, guys. Okay, if you are doing it in the real environment, this issue will not happen to you. Everything will be perfect. So that's why I'm always telling you, take a real Arduino, take real LEDs, take real resistors and real push buttons, real wires, connect, upload and test. Okay, now this is fine, we don't care. Now we are going to check up our functionality. Okay, so now what is the flow? First, second, third, fourth LED. So if I press the button, no matter in which LED we are, immediately everything should go off and it should start from the first LED again. Okay, the blinking should start from the first LED again. Okay, so I'm going to press when it is the third LED. So let's see, I pressed it. Oh man, it was late. Okay, let me do it again. Okay, so let me press. Okay, first second LED, let me press. I press the button. Okay, now what happened? You didn't see it? Okay, wait, this is environment is slow, that's why you cannot see it. Okay, when the LED is coming to the second LED, I will press the button. Okay, so maybe due to the environment is slow. Okay, when this may go up to the third LED, because this environment is slow, it takes time to react. Okay, so then immediately you will see somewhere in the middle this LED will stop and start from the first one. Okay, so I'm going to press it now. Okay, it didn't work. Let's check again. Now let's press. It's not being pressed properly. Let me check again. I'm pressing it now, guys. Oh, I removed it too early. Okay, wait, it was not I mean the simulation environment was not working properly, so let's check it again. Okay, let's watch from the beginning. So I'm going to press. Okay, you see everything went off and it starts from the beginning. Okay, let me now check it out. Okay, not now. When it's in the second LED, let's press. Okay, I'm going to press now. I took my hand off. Oh, it didn't work properly. That means simulation environment errors. So let's check it again. Okay, so I'm going to press it now. I took my hand off. Now see this, everything went off. Okay, and it will start from the first one. You see this? So again, let's do it. Okay, I'm going to press. Okay, see, we start from the beginning. Okay, let's see again. I'm going to press. See, start from the beginning. I'm going to press now. See, everything went off and it starts from the beginning. Okay, let's do it in the third LED. Let's try to do it when the light is in the third LED. I'm going to press and it starts from the beginning. You see, resets. You notice this, right? Again, first, second, third, I pressed it and it starts from the beginning. So don't worry about the time delays and other issues, because these are due to the simulation environments. So please do it in the real environment, guys. Okay, and you will understand the working scenario very perfectly. Okay, just don't worry about the simulation. Still this worked, but our testing is successful because this is working. Okay guys, so I will catch you up in the next video. Until then, stay safe.